and welcome to the Smart Connected World here at PTC Live 2014. We're set up for a really great event here. We have more than 2,000 customers, more than 150 partners. PTC has more than 500 employees here at this event. We've got a great agenda and lots of innovations that we can share with each other. Now, it's fitting that we have the 25th anniversary of this event that's all about innovation here in Boston. Boston is a city that has a tradition of innovation and firsts. You may know that the first university in the United States was Harvard here in Boston, dating back to 1636, only a couple of decades after the Pilgrims landed just down the coast here in Plymouth. Boston has the first public park. Boston has the first public library. The first phone call back in 1876 ever placed was placed here in Boston. The first email ever sent in 1971 was sent here in Boston. And thanks to our own firsts, PTC has become a marquee name in the Boston technology scene. We were the first to make 3D computer-aided design really viable. And we were the first with our windshield product to make PLM on the internet, product lifecycle management, using internet and web technologies really work well. And today, currently, we're the first in our industry to embrace the role of software, of services, and of connectivity in our lifecycle management offerings. Now, on the subject of connectivity, we truly are seeing the rise of a smart connected world. I think we're in the early days, maybe the second inning of a massive wave of new innovation. Let me put it in perspective. Today, according to the US Government Census Bureau, there's about 7 billion people on the planet Earth. About 1/3 of these people are connected to the internet with smartphones and tablets and traditional computers. But in 2010, we hit an important milestone where there were more things connected to the internet than there were people on Earth. So the basic math suggests that these things aren't just smartphones, tablets, and computers anymore. They must be something else. Maybe your Fitbit, your thermostat, your car, you name it. So the trend of smart connected things is really accelerating now. Now there's a computer of sorts inside just about everything. And all those things are capable now of connecting. In 2020, the Census Bureau projects that there will be about 8 billion people on Earth. But many firms are projecting that there will be 50 billion connected things in that same time frame. So in just a decade, we're going from a relatively equal number of people and things connected, well, let me say people on Earth and things connected, to in 10 years, a short decade away, we're talking about 6 connected things per man, woman, and child on the planet Earth. And again, obviously, we're not talking about tablets and smartphones. We're talking about everything around us: cars, buildings, appliances, machinery, farms, cities, hospitals, all kinds of things. Now, there's a massive investment that's feeding this rapid expansion. The market intelligence firm IDC, whose headquarters is nearby in the Boston suburbs, says that in 2013, the Internet of Things solution market had $1.9 trillion of investment. Now, in this analysis, IDC takes a pretty broad definition of the Internet of Things solutions market. It includes the smart connected things, the connectivity services, the software platforms and applications, the security, the analytics, and really everything related to smart connected products. Now, PTC did our own little part to prop up that number because we spent more than $100 million to acquire an exciting new Internet of Things software platform called ThingWorx on the last day of 2013. Now, I promise you'll get a lot more on that later on here in the morning, but that's not specifically the focus of my session. But I wanted to say there's a reason why the world and PTC are making such big investments. And that's because so much value can be created by this phenomenon. In fact, in 2013, the strategy firm McKinsey published a paper, a pretty comprehensive paper, that took a look at the top dozen or so most disruptive technologies. And right up near the top of the list was Internet of Things, just ahead of cloud computing. And McKinsey determined that by the year 2025, this Internet of Things phenomenon will generate $6.2 trillion of global economic value add. Now, in this case, the definition of economic value add means either an incremental dollar of revenue added or a dollar of cost subtracted from what would have been the undisturbed baseline. So this is real, interesting, meaningful value. I mentioned that Internet of Things ranked higher than cloud computing in this analysis. It actually was 10 times larger than 3D printing in terms of the economic value that it will create. And I think, particularly in this audience, we all know how important 3D printing is as well. So the Internet of Things is big, and it's important, and it's real. But I think, personally, most of the world doesn't really get it yet. The Internet of Things isn't about the Internet. The Internet part really isn't changing much. It's all about the things. The things are what's changing. That's where the real innovation is happening. And that's where you come in, because you're the people who create, operate, and service things. You will make the Internet of Things happen. You're going to be the stars of this show. So how did we get here? How did we get to this world of, 8 billion things headed to 50 billion things? Well, first, the computing infrastructure has evolved dramatically. Way back in 1965, Gordon Moore, who was a co-founder of Intel, made the observation that the number of transistors on an integrated circuit was doubling every 2 years at relatively the same price point. Meaning every 2 years we get twice as much computing power for the same cost. Now, that was almost 50 years ago. So in that time frame, we've seen a massive innovation in computing. Now, we all know that because we use smartphones that have more processing power than supercomputers originally did. It's kind of old news, but it's not old news because what's happened is now computing infrastructure has become practical to embed in just about everything at a reasonable price point and with a tremendous amount of processing power. Now, Moore's Law and the advancement in computing infrastructure was followed a couple of decades later by an explosion in communications infrastructure. In 1993, a guy named Bob Metcalfe, who came out of MIT and Harvard and was one of the co-inventors of Ethernet, which you'll know is one of the physical mediums and protocols for the internet, he observed in what became known as Metcalfe's Law that the value of a network isn't directly related to how many things are connected, but in fact it's proportional to the square of how many things are connected. Actually, the equation is n times n minus 1 over 2, which means if the world had one telephone, it would produce 0 value because there'd be nobody to talk to. But with 2 telephones, we can have 1 conversation. With 3 telephones, we can have 3 conversations. With 4 telephones, we can have 4 times 3 is 12 divided by 2, 6 conversations. And we go on, 5 phones, 10 conversations. A dozen phones, 66 conversations. Now imagine when we extrapolate that up to more than 2 billion people on Earth being connected. You can see that this level of connectivity has literally transformed life on Earth. So today, connectivity is everywhere. There's, of course, cables. There's Wi-Fi, there's 3G, 4G, Bluetooth, satellite, you name it. So everything not only has an affordable computing infrastructure, but it has a practical means to connect at a reasonable price. Imagine when we have 50 billion things connected. So given this inexpensive computing and this pervasive networking, we have all the ingredients except one, which is the innovations you need to do to create this concept of smart connected products, which are the things in the Internet of Things. Now, we at PTC could see the power of what was building, and more than a year ago, I, together with the help from a number of my staff members, began a research project with Professor Michael Porter. Michael Porter is the famous strategy professor from Harvard Business School. We began a research project on what does the evolution of smart connected products really mean. And our findings are going to be published in Harvard Business Review later this fall. But to preview them a little bit, what our findings show is that the explosion in smart connected products will redefine value chains. It will impact industry structures, and it will change strategies for competition. It's going to be a big deal for everybody. It's even a bit scary, but I think personally, change is good. It's good for you because it creates new opportunities, and it's good for PTC for the very same reason. I think everybody in this room will be participating and being affected by the explosion of smart connected products. Now, I keep talking about smart connected products, and maybe it's a good idea to baseline, what are you talking about? So we've created a bit of a taxonomy to help you understand the architecture of a smart connected product. And it starts with the mechanical and physical part. Now, if you go back any amount of decades, that's all there was. This is sort of your father's product. It was a physical product. It was made of mechanical and electrical elements. The electrical elements weren't used for computation and logic processing. They were used for energy and motion and things like that. Now, this physical and mechanical part is still very important. And we at PTC have been helping customers optimize mechanical design with 3D CAD products like Pro Engineer and now Creo since our inception. It's really our heritage. And mechanical design remains the lifeblood of many of our customers. So while physical product design remains the foundation for product value, I'm putting it in the category now of necessary but not sufficient. You're going to need to do more than that. So the next dimension of the architecture of a smart connected product is the smart part, the smart dimension. And by smart, I mean sensors that sense what's going on. They're connected back to some type of an electronic microprocessor. That microprocessor is probably processing software algorithms to help with, sort of the if-then type of statements and logic and control. And then there's very likely some kind of a human user interface so that the human can participate in the monitoring and control of this product as well. Now, if you own a coffee maker and you bought it in the last couple of years, you have all of what I just said there. Now, one of the things that smartness does is it creates incredible new dimensions of value in a product. Having used a smart coffee maker, I don't really want to go back and use a dumb one again. There's just too much more value in a smart one. But it also makes designs a lot more complicated. And therefore, the need for product lifecycle management and solutions like our windshield technology is bigger and stronger than ever as products become smart. But it also brings up some design challenges that now we're talking about some complex design questions like where do we use sensors? Where do we use software? Where do we use hardware? How will the hardware and software work together? So it's not just design, it's systems engineering. And PTC is stepping up in this area. I don't know if you noticed this morning, but we put out a press release that PTC is acquiring the UK-based company called Atigo to get our hands on their best-in-class artisans systems modeling and engineering tool set to bring into our application suite, because we know how critical systems engineering is to products going forward. Now, the third dimension of a smart connected product architecture is connectivity. Now, connectivity might be wired or wireless. It might be point to point. It might be hub and spoke, where like a whole fleet of products connects back to one single cloud. Or it could be mesh, where everything's talking to everything in a many-to-many type of connectivity scenario. Now, irrespective of what type of connectivity, the ability to get data to and from a remote product really allows us to optimize how we create, operate, and service that product or that thing. Now, we shouldn't think of products as being just products. There's sort of a range of possibilities here. On one hand, some products are just products. My coffee maker could be a standalone coffee maker, and my ability to interact with it remotely could create a lot of value. So there are many things where we can create value on a one-on-one basis by optimizing the availability of that thing or optimizing the operation of that thing. But a lot of times, the thing is a system of things. It's a system of smart connected products working together. And sometimes those systems have a lot of structure. They might be things working together collaboratively in a coordinated way in a factory to try to make the process of that factory more effective and more efficient. Or it might be a very diverse range of things in a complex, unstructured, almost organic type of system, like traffic flow in a city of Boston, or the whole city infrastructure as a thing. At this point, we're not completely in control of what's going on, but we want these things to work together and to work with us and all of our algorithms so that, for example, we can optimize the response of that system to some kind of an unexpected disturbance, like a snowstorm or a major accident that ties up traffic on one of the main thoroughfares. So we can think about how to optimize and reroute and so forth. Okay, so the world is changing. The products we create are changing. And the sources of value in these products is changing and shifting around. And if you step back and think about how is value in products changing, I think there are three big changes in the sources of value. The first big change is that hardware is increasingly sharing the stage with software. There's much more value coming from software than there ever has been before. I talk to customers about this all the time, and customers say, yeah, we have 1 million lines of code, or 5 million lines of code, or sometimes 10, 20, 50 million lines of code in their products. And these are products that a couple generations back were pure physical, mechanical things. Some of you now have more code in your products than we do in our products, and we're a software company. I mean, it's really pretty incredible. But it's not just that hardware is being eclipsed by software. In fact, there's a virtuous cycle of innovation, that new innovations in software enable new innovations in hardware. I mean, every smartphone has an accelerometer in it today, and it didn't a decade ago. And that's because it's so useful to think about how software and hardware could work together. We got rid of keypads by and large, and we have touchscreens and so forth. Again, it's a virtuous cycle of mechanical, hardware, and software co-innovation going back and forth. So the second big value change is around connectivity, which gives us new options for software. It enables us to do new kinds of smartness, if you will. A good example is the Bose radio shown here on the screen. So the previous generation Bose radios, Bose makes very nice radios, local company, customer of ours. The previous generation was pretty physical. We had physical media for the music. We have physical controls, physical lamp, physical speaker. Wasn't long ago, this was state of the art. Now, this is state of the art. Today's Bose radios don't have any physical media. They get that from the cloud. They really have very little user interface. There's a few buttons here on the top, which are really presets, like you used to have in your car, still do to a certain extent. And the presets are configured by using an app on your smartphone. You could say, preset number 1, I want to tie into a playlist in iTunes. Preset number 2, I want to link to my favorite, French internet streaming radio station. Preset number 3, I want to hook into my channel on Pandora. And I'll configure it all. Now, it actually makes for a much simpler product. So now we get the question, where should we put the software and the smartness associated with it? Should we embed it in the product or put it up in the cloud? And I would say, quite frankly, there's advantages and trade-offs to each. The embedded software you put in the product certainly is going to have better response time. It's not going to have a dependency necessarily on the availability of the network, which, by the way, means that it probably has fewer security issues. So when people put products or put software into products, many of them use our integrity software because it's a great way for managing that hardware, software, systems engineering type of process. Now, when it comes to cloud software, there's a tremendous amount of action going on because cloud offers some interesting new and remote capabilities. In the cloud, I can blend together many sources of data. Internet streaming radio, iTunes, Pandora, you name it. I can offer much richer user interfaces. I can build a much better user interface on a smartphone or tablet than I ever could build on a mechanical physical device. And it's easier to change. Last time I plugged my Bose radio in, it said, pardon me, do you mind if we download an upgrade? And I said, sure, go ahead. So it's an evergreen product that continues to get better as I own it, which is not really typical of the traditional world. So when people want to put software in the cloud, that really brings us to our new ThingWorx platform. It's an incredible tool for adding smartness to your product that's not just in your product, but up in the cloud, interacting with your product, and many other sources of information. So we think probably you're going to do both. You're going to put smartness in the product, put smartness in the cloud, and we're in a position to help you on either end of that spectrum. The third big value change is the old product versus service discussion and the sort of business model implications that go along with that. So once again, smartness and connectivity open up a whole new world of possibilities. Now you have the question of, should we deliver the value of our things as a product that we sell? Or should we bundle that product and some services that go with it together so that we have an initial transaction and then a follow-on relationship? Or should we forget about selling the product entirely and just use the product as a means to create a service, and it'll be the service that we sell, perhaps on a subscription basis? I ran across an example recently from Philips Lighting that's really intriguing. So Philips Lighting recently entered into a contract in Washington, D.C. to provide lighting as a service for parking garages. Now, Philips, of course, is going to use LED lighting. And if some of you have purchased LED lighting, you know that it's quite expensive to purchase up front, much more costly than traditional incandescent or fluorescent light bulbs. However, it consumes a fraction of the electricity as you use it. So the benefit comes over time, the detriment is a higher upfront cost. So what Philips did was entered into a contract to provide a lighting service for 10 years. So they're saying, you don't have to buy the light bulbs. We'll install the light bulbs ourselves. You will subscribe to the idea of having well-lit garages, but I get most of the energy savings that you're going to have over the next decade. But it's Philips' responsibility to maintain and keep this system, optimized, which of course is a lot easier to do with smart and connected products. So that's just one more example of what seems to be an unstoppable evolution from transaction-based sales to bundles of products and services, you know, spare parts, extended warranties, performance-based contracts, all the way up to product as a service. And at each level, our service lifecycle management solutions have proven to be quite useful in optimizing the way that that's done. Okay, so I've talked about how the architecture of products is changing. I've talked about how the way we think about value, hardware, software, embedded versus cloud, product versus service, how that's all changing. But, you know, what does this do for us? What's unique? What can we do now with smart connected products that we couldn't do with the previous generation? So once again, we've developed a bit of a categorization, let's say, of the new capabilities of smart connected products. And we think there's maybe 4 main types of new capabilities. The ability to monitor the product remotely, the ability to control the product, the ability to optimize the product, and the ability to actually automate the product. So let's take a bit of a deep dive into some examples. So the first new capability is monitor. You know, there is no need in this new world to be physically coincident or proximate to the product. In the old world, if you want to know what the product's doing or how it's operating, you have to be where the product is, which means you need to get in your car or truck and drive to the product, or you need to put that product in a car or truck and bring it back to you at the dealership. Now you know what's happening, okay? In the new world, we don't have this need for physical proximity. We now can determine the condition of the product, the environment of the product, and the operation of the product remotely. So a great example is a biotronic pacemaker. I think everybody knows what a pacemaker is. It's embedded inside a human thing. The connectivity here to the pacemaker allows the physician to remotely monitor what's going on with the patient's heart condition. And Biotronic, by solving this problem, has actually positioned themselves to rethink about their business model a little bit and to think about, should we be providing home health monitoring as a service rather than selling pacemakers as a product? Now, all this stuff here, it's not just fantasy or obscure business-to-business use cases. I mean, I would argue it's becoming part of our everyday lives. My mother-in-law was with us over the weekend, and I was talking to her and my father-in-law about smart connected products and the Internet of Things, and she never really heard of the Internet of Things, but she went on to tell me about how her new Buick sends her emails commenting about the tire pressure and when it's time to change the oil, and I said, there you go. Your Buick is a thing on the Internet of Things. It was pretty exciting. Now, in my own case, I kind of had an interesting little surprise. I have a barn. I live about 20 miles away, and I have this beautiful barn with this big solar energy system I installed on the roof. And much to my surprise, I didn't ask for this, but it came with an internet web monitoring system so that I could monitor it remotely. And it proved to be quite interesting and useful, and just for fun, I want to show you how it works. So here we are. You can see we're right around the 8 o'clock hour. We're getting 0.8 kilowatt hours of electricity right now. You can see to date, I've generated 37.27, let's call it, megawatts of power. I can say what's happened this week. And I can see that, quite frankly, the electrical output fluctuates day by day, and that's because some days are sunny and some aren't. I might say what's happened this month. I can see it by days, and you see pretty wild fluctuations. So I like to play with some of these reports. I can drill down, and I can say, show me how many dollars I've saved over the last year. So this is kind of interesting. I've saved $3,736 and change in electrical costs over the last year. And it fluctuates by month here. You can see this month I had $356 and $359, but in December, I was way down to $150 worth of electricity. So this tells me how much money I'm saving, but I don't know if it's good or bad. So then I can run a report that says, well, show me how much I generated versus what should have been expected. Because this report factors in seasonality. and the different types of weather you'd expect in the Boston area in different months. So the green bars say this is what you should have generated, and the blue bars say this is what you did generate. And I can see that most months I'm kind of outperforming the benchmark, except in this month of December I actually did fall below the benchmark. Now, what happened in December? Well, one of the things that happened is there was a lot of snow. And a lot of snow sat on those solar panels for a long time, and of course, they don't work near that well when they're covered with snow. So that's a kind of interesting example in my own home life of where the Internet of Things sort of snuck into my life. So let's go ahead and move on to the second new capability, which is control. So, like monitor, we used to have to be where the product was to control it. You have to be sitting in the car to steer or to accelerate or to brake. Now we can have remote control. We can control both the configuration of the product as well as the operation of the product remotely. So a simple example is this thing called a doorbot. So a doorbot is a remote doorbell. So when a visitor rings this doorbell triggers an alert on your tablet or smartphone, and it launches an app. And through that app, you can see and talk to the person who's standing at the door, and if you so choose, you can unlock the door remotely and let them in. So that's an example of remote control, pretty simple, but quite frankly, pretty useful. It would be much more powerful to think about scenarios like remote control of fleets of machines, machines acting together in a production line on a factory, or machines that are underground in a mine, in a mining operation, to make sure that the productivity of that operation is high, or machines, oil rigs, valves and pumps on offshore oil rigs, so that you can monitor what's going down and what's going on and shut it down if there's a problem and so forth. So once again, I have a scenario where this is showing up in everyday life. So it's not just doorbells. You know, if you watch TV now, you see the commercials from Verizon and Comcast who offer home automation services. If you breathe, you probably heard that Google bought Nest for a fortune. You might have heard that 2 weeks ago, Apple launched a strategy to get into the automated home and home automation. Well, it turns out, in my little world, I also have a home automation system. So let's take a look at that just for fun. So in this particular situation, I'm looking at the playroom, which is a room in the basement of my house. And I can see that it's 68 degrees, and that the heat will come on if it drops below 60, and the air conditioning will kick on if it goes above 72. Now, I might say that, you know what, 60 is a little cold, so why don't we crank that up to like 66 and have a slightly narrower range that's a bit more comfortable. So that's the thermostats. Let me come back to the full control I have of this room and most other rooms in the house. You see, I can control what's on TV, I can control what's playing in the speakers, I can turn the lights on and off, I can play with the security and the thermostat and a bunch more things. So funny enough, I actually see at the bottom here that the TV's on. Well, some of you remember that's part of the commercial that plays on TV is, uh-oh, we left the TV on. Can we go turn it off? Yeah, we can. I'm in the process here of turning it off, and it'll go away in a second. Maybe what I'll do instead is turn on some music. So I'm going to go and say I want Sonos to play in that room. So Sonos is loading up now and taking inventory of my different online music systems. Hopefully this will go fast. I think I didn't quite get the TV shut off. Let's try that one more time. Anyway, you get the gist of it. I don't have enough time to play with it. So anyway, that's sort of an interesting example of control. I better take these glasses off. So the third capability, which I don't have a demonstration of, is optimize. By this I mean optimize the performance of the product by changing your strategy depending upon what you see. And of course, optimize the uptime by monitoring the conditions that are developing and trying to intervene or change things as need be. So, a simple example that's real would be imagine the ability to reconfigure a bank of elevators in a tall office building by dynamically dividing them into short haul and long haul routes depending upon the traffic that's trying to get in and out of the building to different floors. at different times of the day. So you can be very dynamic about this, and every time you walk up to that elevator bank, they might be configured differently. Now, it's a good idea because every elevator shouldn't have to stop at every floor, which is kind of what tends to happen if you don't intervene and optimize and divide them into long routes and short routes and so forth. So that's one example. Other examples would be tractors or heavy machinery, where you can actually optimize the horsepower of the engine, increase, decrease the horsepower, burn more fuel, less fuel, depending upon the load, maybe sell the upgrade to the customer because they're now entering a new domain with your product and they need more from your product and you need more revenue from them in trade. So that's all, the ability to intervene and reconfigure the remote software. Another example would be remote diagnostics and service, where you actually log into that thing and find out what's the problem and fix it. Or you push upgrades out to it each time you have a patch or a new feature, like Bose did for my SoundLink system recently when I logged in. So optimize is a third category, and then the fourth new capability is automation. And by automation, I really mean having very sophisticated algorithms that can consider many different sources of input and data, such that they can analyze the product's performance and its environment, and then have sort of real-time reaction to what's going on. So a fun example that's here at the show is this yellow thing called a bioswimmer from one of PTC's partner, Boston Engineering. Now, I would call this thing a fish bot, but they actually call it a underwater autonomous vehicle. But it's designed to mimic the shape and the motion of a tuna so that it can stay on course and achieve its mission independent of currents and waves and things like that. And a device like this is used to map out terrain or perhaps perform some kind of search and rescue or something like that. So autonomous products can act alone, as this one does, unless they've taught it how to be a fish in a school of fish. But they can also act in coordination with each other. And again, we're approaching the day where it'll be commonplace to see smart factories that contain smart connected things that are working pretty much autonomously to create smart connected things. It's a pretty exciting vision, and I think it's more real than people think that it probably is. Okay, so I've talked about the fact that products are changing, and it's creating a lot of new capabilities and values moving around. But let me try to boil it down to why it's important to me, to PTC, and I think to people in the room here. Most of you are here today because you rely on PTC, or maybe you have an interest in relying on PTC to help you create, operate, and service products across their entire life cycle. Now, I want to look at this word life cycle for a minute. Our industry uses this term all the time. We talk about product lifecycle management, application lifecycle management, service lifecycle management, and so forth. But I might argue the term's been a little bit misused, because while we know everything there is to know about the product when it's in engineering, and everything there is to know about the product when it's in manufacturing, to be frank, we lose sight of it once it leaves the factory. It's what I call the far side of the moon problem. So think about spacecraft. Spacecraft has this challenge that as they move behind the moon, we lose sight of them. We can't communicate with them. So we cross our fingers and hope and pray that that thing emerges on the other side in a healthy state, because there's going to be a period of time where we don't know what's going on. Now, the problem is in product lifecycle management, that period of time could be decades. It takes a year or two, or maybe 3 or 4, to engineer a product, depending on how complex it is. But then these products operate for 10, 20, 30 years. And it's a shame to think we're doing lifecycle management if we're actually only seeing the product through a very short period of its life cycle. But what if you could stay connected to this product for its entire life cycle? What if you always knew what was going on, how your product was being used, how it was performing? Well, that's the vision that's really been driving our thinking at PTC. That's why we assembled all this technology for what I call closed-loop lifecycle management. We can help people do the physical part, the hardware design, with Creo. We can help people do the software design with Integrity. Now, thanks to Atigo and Artisan, pretty good systems engineering tools. Of course, our Windchill software can manage all those configurations of hardware and software and changes and enable global collaboration and so forth. Our service lifecycle management solutions are pretty darn good at optimizing the product throughout its fielded service lifecycle. And now, with ThingWorx, we have that connectivity platform that allows us to have this vision, this dream of closed-loop lifecycle management. There is no other solution set like this in the world today. PTC is unique. We have a strong, compelling vision. We're committed to it. We're investing in it like crazy. We think that that vision and that concept is what will enable you to dramatically transform the way that you create, operate, and service products. And that, in turn, will be the basis for your own product and service advantage. So in closing, I think this is the most exciting time in our industry that I can remember, and I've been here for a while. I want to remind you, there is no Internet of Things without your things. So you each have a critical role to play in making this story come to life. We're entering a very exciting era, and this time, you're the headline act. Thank you very much, and thank you for the investment of your time and money and energy to be with us here at PTC Live 2014. Have a great show.